Hey Sharks, I'm Jordan.
I'm Sam.
Hello, my name is Thomas Close, and I'm a fourth-year bioengineering student.
I'm Chris.
And I'm Lucas, and together we are BioE Group 7.
Bacteriophages are viruses for bacteria. They work by infecting a cell with their DNA and using the cell's machinery to make more of themselves until the cell bursts, which is known as lysing a cell. Bacteriophages are one of nature's answers to bacteria. Humanity's answers for the last 100 years have been antibiotics. Antibiotics work by stopping cells from replicating at some point in the process, which is usually DNA and RNA replication. The problem with antibiotics is that they can be overcome through natural selection, and rampant misuse can render them ineffective. This is unfortunately the stage we humans are in now, the beginning of antibiotic resistance, meaning that otherwise simple infections that were treatable can now kill quite easily and do. 20,000 people were killed by methicillin-resistant Staphylococcus aureus infections in the US alone in 2017. Staph is one of the antibiotic-resistant superbugs out there currently. Bacteriophages, on the other hand, cannot be overcome. Some bacteria are more resistant than others, but none can stop a bacteriophage's infection. The best part is that bacteriophages are specific, meaning that they do not attack other bacteria or other cells.
The MR11 bacteriophage production process occurs through the amplification of bacteriophages in a bioreactor. An initial seed train of bacteriophages is inoculated into a 70-liter bioreactor, together with S. aureus and growth medium. The medium is sterilized using a plating frame heat exchanger prior to addition to the bioreactor. In the bioreactor, the bacteriophages infect the S. aureus cells and multiply, lysing the cells and amplifying the number of bacteriophages. For this process, cultivation occurs over a span of 36 hours before being transferred into a holding tank. The bacteriophages are then clarified using a centrifuge and transferred to another holding tank. The bacteriophages are directed to a two-stage diafiltration step to further remove cellular debris, with the bacteriophages flowing in the permeate. The diafiltration step uses a microfilter, which allows bacteriophages to fit through the small pores of the filter, while preventing larger material to flow to the product stream. Next, the bacteriophages are run through an ion exchange chromatography column, where they are captured in resin before being eluted with an elution buffer. Finally, the bacteriophages are run through an ultrafiltration step, where they are captured in the retentate. Small particles flow through the permeate, where they are transferred to wastewater treatment. With the bacteriophages now captured, they are then sent to a lyophilization step for packaging.
There are many different types of engineers that work in a bioprocessing plant and contribute to the design and operation of said plant. Today we'll be focusing on process and validation engineers. Process engineers are responsible for the initial design process and implementation of new production scale plants. After construction, process engineers play a key role in ensuring the plant is running smoothly, that all equipment is functioning and up to code, as well as managing operations. Validation engineers are responsible for making sure the product quality is appropriate and that each step of the process is within expected parameters, whether it be temperature, pressure, product concentration, or other factors. They play a particularly important role in our process because the bacteriophage is a heavily regulated pharmaceutical product and requires continuous monitoring by the FDA.
Thanks, Chris. Now, the United States Food and Drug Administration is the predominant body responsible for making or breaking a biopharmaceutical product. And to quote Dr. Kelly, if the feds want you, they gon' get you.
Chief Wiggum back in pursuit of the rebelling women.
All right, your current location?
I'm on a road, looks to be asphalt, trees, shrubs, I'm directly under the earth's sun, now.
This is why we chose to prioritize current good manufacturing processes, or CGMPs, such as cleanability of equipment, separation of manufacturing areas within the plant to avoid cross-contamination, clean rooms for bacteria purification and bioreactor seeding, as well as phage isolation in a separated lab. Additionally, our team chose to utilize a strict validation process prior to startup for our purification of the Phi MR11 phage. This validation process will work in tandem with the pre-approval process for the FDA, allowing us to validate our initial pre-processing costs by a presumed low failure rate and regulatory burden.
With our rockstar team of group members, from the suave Sam Melvin to the trusty Thomas Close, we have carefully considered the various components of the bioprocess design and its operation, its economic viability, and the regulatory considerations required to create a successful bacteriophage production facility. We are confident that the process proposed to you today could provide the world with a robust and biochemically homologous solution to the oncoming threat of bacteria superbugs such as MRSA, VRE, and Salmonella. Thank you for your attention, and as always, it's been a pleasure.